Hello everyone, and welcome to today's live stream where I made a nice little everyday geometry node group asset pack, which is currently up on Gumroad. And yeah, I'm going to be going over what these nodes do and how, practical use cases and all that good stuff. The one thing, it is ungodly warm today over here in the northeastern US, so the stream will be fairly short and sweet, hopefully. Oh, and I just noticed that OBS is scaled wrong, which is hilarious. But I'm not going to deal with that. I'm going to assume that that's just a rendering error with this version of Blender. Now, this node group pack will work with Blender 4.1 and later, though right now I'm running Blender 4.4, and I turned off the Vulkan experimental rendering engine, which I assume makes that little weird border at the top there. But again, let's not worry about that all too much. So let's get into it. So we have a good selection of nodes right here. I'll go from left to right. We have the UV tangent node, the SDF Mesh node, in the read section, in the deform section, the normal displace, and the SDF collision node. And in the generate, we have solid extrude, circular array, curved mesh with UVs. You know, that the name is a little bit cut off there, so let's just go and show it. Come on. There we go. Curved mesh with UVs, and then point grid 3D, and then velocity step. Now, these are just nodes that I've made as I've been working on various projects where it's just like, you know what, I don't want to create that every day or every 5 minutes, so might as well just have them around. So let's start with, I guess, point grid 3D, because that's a generate one. So here, we can just see that it creates a point grid, as you would expect. And, you know, pretty straightforward. It just gives you points in a 3D grid. You can change the amount and all that. Starting, you know, it just sets it like that, so you can set the amount of ones like that. This one, you know, it's kind of niche, but it could be used. You get the UVW, the normalized position, even when the increment scaled, it does that regardless. You know, pretty simple, pretty good. And then you can choose whether these cells are centered. So in this case, they're centered in the middle of the cell regardless of the increment, or you can have it so that they're at the floor of it, which, you know, could be pretty useful. And I can showcase one of those examples later. But yeah, so that's that one. Solid extrude, as you would expect, just extrude, but it is solid and it has the mid-level just like the regular solidify node. Very simple. Curved mesh UVs, let's go and do that one. I know I'm kind of going a bit fast and haphazardly, but it's very hot here in America, and I don't want to drag this out all too much. So curved mesh with UVs. Say you have two curves, and they're both cyclic. Well, with the old curved mesh node, there we go. We'll see that if you try to capture, let's see, capture attribute. Let's put this here. Let's go and get the spline parameter. Again, this setup is very annoying to do every single day, so it's just not worthwhile. But here we can see if your spline is cyclic, that it just doesn't loop properly. This should be a harsh cutoff, and it is not. So I decided, you know what, let me make a node group where it, you know, doesn't deal with that. It just outputs the UVs. You don't need to worry about it, and it just works. Now, I know that the Blender devs have, or community devs or Blender devs have considered adding a UV output to the regular node, but there were settings like, oh, do you want it to be with the length or with the index and yada yada? But my solution to that would be just, oh, just capture the length and then multiply the UV by that later. Simple enough. But yeah, for this one, it's just that. Short, sweet, does what it says on the box. Okay, point grid 3D, and then circular array. Let's go and get a nice cube. So circular array, I've seen people use something like that in the past, and it's been useful. So again, you just have a circular array, you set the center, you set whether you want the local rotations to be enabled. Here, let me go and give it a bit more room on the sides here so that you can see what's going on. But again, it could be like, actually, let's go and get a monkey in here. Go, let's put this in the middle there. Go and get the outliner out. And again, these are geometry node assets, so once you put them in your asset library, outliner viewer, once you put them in your asset library, they will just be searchable normally, and it'll all be good. So again, here we can see that they can either follow their local rotations or just be arrayed in a circle. With the controller, you can make it so that there's an object controlling it, but that's, you know, just an optional thing. And then, yes, you have the angle right here to say, how far you want it to go. You can set the amount, classic stuff, and then you can set the rotation axis. Again, simple stuff, just helpful to have around. So that is that section done. So these next ones that I'll showcase, the velocity step, SDF collision, and SDF mesh, are just a tad more. Actually, you know what? Before we do that, let's use the normal displace. This one is kind of like the displace modifier. So let me subdivide the mesh a few times and then just displace it. Let's go and delete the monkey because we won't be needing that for a few minutes. Again, with this one, you just plug in a texture and it displaces it along the normal, like the displace modifier. Pretty simple. You can set the strength and the mid-level. Again, does what it says on the box. Fairly simple. And that one is good. So yes, the last ones, do we go with, yeah, let's do UV tangent and then save the best for last. So let's go and, well, just reset that. Let's go and re-add the monkey because this one is actually necessary to showcase the UV tangents. So let's go and get the UV tangent node group right here. So with this one, it'll give you a UV tangent. So if you have a UV map on your mesh, I'll go and give you the tangent by tangent and the normal. So if you're wondering what this is useful for, it's if you need to let's see, let's put this up here so that we can have that right there so that we can see it. If you want to, say, deform something like fur on top of a character, you need the tangent in order for it to accurately be displaced. And with this, it just makes it a lot easier because internally, it's a bit of a headache to go and do yourself. So just a node group. I think a community developer was planning to get one of these nodes into 4.5, but I don't think that went through in time. So this is the best that we have at the moment, and I've been using this one for maybe 2 years now, just because, again, very useful, very simple once you get it figured out. Okay. So we have that one, and now all that's left are these simulation-based, or not entirely simulation-based nodes, but I think you'll get what I mean in a second. So let's start off with SDF Mesh. As the name implies, this gives a signed distance field based on a mesh. So let's go and put the monkey into here. Let's go and add in a grid, just so that I can set the amount of subdivisions and all that good stuff. So this will give you the signed distance. Let's go and make the grid a lot bigger. So here we can see that that works out just fine. There we go. And as a radius of 0, so here we can adjust how far the SDF goes along. And this is important when if you have like particles with a radius, you plug in the radius into there and it makes the collision work properly. But here inside will be negative, outside will be positive. Well, the regular geometry proximity node will not tell you whether you're inside the mesh or outside. And this will give you the SDF and the normal, which this one is also very important for collisions. It also gives you the base position of the object and the offset to make sure that points are outside of the object. So if we use, say, a set position node, this one's just for convenience. You just put that there and it's like, oh, okay, the entire grid is outside the object, which is nice. Okay, even though, wait, I think I might need to make it so that nothing happens with stuff outside. I may need to fix that. That's also why I do these little reviews, to make sure that, yeah, to make sure there are no bugs. That might be, I may need to fix that, but that won't be difficult. But yes, that one does that. So, next up are the SDF collision node and the velocity step node. So let's go and get some particles in this place. So let's go and distribute points on faces. Let's go and move our mesh plane so that we can have quite a few points up here. So we're going to make a basic particle system using this. So we're just going to have this, couple of particles, just like this. We can see that nothing happens. But if we use the velocity step node, plug it in there and attach the delta time, because this is delta time compatible. I got so frustrated with having to make this entire node group every single time that I was like, let me just make one and forget about the rest. So here we can see that it falls according to gravity, which Blender's old particle system didn't seem to be delta time independent, or like frame rate independent with delta time from my brief testing. But with this one, if you set it to be 60 or 24, it runs, or it'll fall at basically the same rate. There will be a little bit of an error, but that's fine. It has damping, which uses delta time based mixing, so over 1 second the velocity will go down by half and that'll be good, but here we're adding more velocity and all that stuff. You can also set the velocity, so this will go down at a constant rate instead of completely adding it, just to simplify the process if you want to do that. But you may be wondering, wait, it's not colliding with the object. How do we make it collide? Well, that's where the SDF collision node group comes into play. So let's connect this right here, and we can see that nothing happens. That's because we need the SDF. So let's go and get the SDF Mesh node, plug this into here, and we'll plug in the signed distance and the normal into here, because for collisions, you just need a signed distance and the normal to check if you're inside the mesh, how far inside the mesh, and the normal to know which direction to go to get outside of the mesh. So we can see right here, when we play this, the particles bounce off and then they fall, which is very nice. There are options for friction and bounce. These are pretty good. Could use some improvements when the friction is set all the way up, and like the bounce is set down, there will be just a little bit of movement. But overall, it's pretty good. Let's do that and set the bounce to 1. There we go. So again, with 3 nodes, again, I could combine these 2 into 1, but I want to keep them separate because this node could be useful outside of just that. So in this case, if we go and copy U, this will work with the points just off base. So here, if we go and move U down, we can see that the particles do move outside of it, even if there's no velocity attribute. But it's there if you want to do it. Okay, so those are pretty much the nodes. Again, simple stuff, just parts where I'm like, I don't want to make these nodes every day for the next who knows how long. Like, oh, I need to make a basic simulation system, and I don't want to do the whole shebang. I don't want to bring my entire particle system into here. Just a little velocity step. I don't want to worry about delta time, little collision thing, and that's all good. And then that's that. So again, here are the nodes. More will be added over time. Maybe a particle self-collision node will be added as well, because that one could be useful. And then maybe some relay integration, possibly. But yeah, these are just the basics. Oh, also you get the is hit value and the hit normal thing out there, because that's useful information if you want to make a larger particle system. Again, simple stuff for just to make your setups a bit easier to do. Alright, so that's that. Oh, and also you get, with outputs, you get the original normal of your object with the solid extrude, the top and the side. That we already went over that, and then the SDF. This one I might need to fix a little bit, but that should be fine. But yeah, also I forgot to get the link on Gumroad, so let me get that real quick. I'll also read the chat while that's all loading. Let's see. You're better than a Blender dev. I highly disagree with that. With your potential, you could do hardcore things, bro. You're a magician. I disagree that I'm better than a Blender dev because my coding skills are extremely basic. The only reasons I've been able to get or create 2 nodes into Blender 4.5 is because I've had help from the Blender devs, and I just copy parts of nodes and then stitch them together. Also, here is the link to the asset pack on Gumroad, so that you can just pick it up. Again, I'll be making adjustments and adding more nodes over time. Just again, if you find it useful, it's there. Let's see. I know that tangents are also used for normal mapping, so how are those generated on the back end with meshes with no UVs? Well, that's the fun part. They aren't. So if we get the UV tangent the tangent node here in the shader editor, and this is using OpenGL back for alright, wrong object. Let's go and do that here. So if we look at this, without any UV map, it just uses the z-axis. So it's taking the normal, cross-producting it with the z-axis, just with z equals 1, and then that's that. So that's how you do it without any UV map. And then the other option is a UV map, which there is no string input for this, which is very annoying when trying to make shader node groups with that. But then again, the shader editor needs a bit of an overhaul with all these becoming inputs, like what's happening with the compositor. But the shader editor does not support constants last time I heard, which is why things like that and the image texture don't have inputs, which, again, that's these, or mainly this right here, is a big inhibitor for shader group assets. Like, anytime there's someone who wants to do, I don't know, make an effect where you just put in the diffuse normal roughness, you can't do that with a node group, you just have to pass it in. So it's, again, very, very annoying, but it just shows that the shader editor needs an overhaul like the compositor, which probably will happen in the future. It's just a matter of how long. But yep, that is that. So, any questions on the nodes? I know they're pretty simple, but, you know, they do what they say on the box. Like the SDF ones, you know, those ones are a little more out there. Quite a few people don't know about sign distance fields, which is fair. But yeah, it's just distance and then it's signed, which means that there's, you know, there's a positive and the negative. And then you get the position and normal, which are the essentials. And then to fix the position part, or the offset, I just need to add in a min or a max. This one right here. I would just need to do that. And then, let me test this with the grid, set position. This should be a very quick fix if I do it right. So plug in the offset. Again, that's just for convenience. If we bring this down, is that because the radius is 1? Yes, it is. The radius should be 0 by default, but I set it to 1 just for a little explanation, but I should keep it at 0 for the default. But yeah, you just have that, so I need to just plug in a maximum. Yeah, missed one node, but that'll be quickly amended. All the other inputs work out just fine. This gives the original position, not offset, so that's just to get the base stuff so that you don't need to add in more nodes. Yeah, and the normal, it's interesting. The normal here is not just the surface normal. You have to get the point normal so that there's no float point precision errors. But the actual normal that we're using here is the normalized position. And don't worry about all this. There are different... Oh, I forgot to showcase that. One second, everyone, while I go and get another grid. That we can take a look at that. Let's go and get the monkey head over to here. Plug that into there. There are different modes. So like the geometry proximity mode, proximity node, we could go on faces, edges, points, but the fun part here is that, oh, that's too many cells in the grid. Let's set this to 128. There we go. The thing is, we can set it to be points, edges, and the mesh is too dense, so let me go and reduce that by a bit to the low poly model. Now let's take a look at it. Still a bit too high poly, but here we go. It'll give you the sign distance and the normal for the points or the edges, so you can make particles collide with both of those. Again, as we can see there. So yeah, actually, I can do that right now. Let's go and see what the particle system looks like colliding with only the edges of this object. Again, it'll look a little bit weird, but it'll be fun. Again, right there. Oh. Since the radius is 0, they just phase right through. So let's go and put in the radius of the particles into there. So we should see, yeah, some of them bounce off, but it's just where the edges are. And then if it's points, some of them will bounce off, but it's only, you know, imagine this was just points and then, you know, that would work out just fine. Okay, so what's the benefit of using SDF collisions as opposed to raycasting? Well, the main thing is with raycasting, it doesn't work well with radius, or radii. If the particle is moving, if you have a raycast, and the particle is already moving outside the mesh, it won't, or wait, which one is it? Raycasts, as I've tested them, aren't great when it comes to collisions with particles with a radii. Because if the particle is inside the mesh and it needs to go outside, it goes out, and then, yeah, from my testing, it's been a pain. Though I switched to using just SDF collisions or just geometry proximity collisions just recently. I've changed it to actually use SDF ones. But this method is just better because it just gets the closest surface no matter what direction. Because with raycast, you need a direction. With this one, it just gets what's closest. So just deal with the collisions as they come. So they're just a bit better in that regard. Just less of a headache to deal with. Now, in some cases, you will need multiple stub steps if there's like two objects close or two faces close to each other, but you would have to do the same with raycasts. Again, this one is just more reliable than raycasts, and you don't need to deal with a direction. Yep. Okay. Let's read the previous comment. Okay, I read somewhere that it just uses basic projection like a cylinder, but that makes more sense. I guess... yeah, it is kind of a cylindrical projection for the UVs. As, again, let's go to the shader editor. Let's go to tangent right here. Because it's just the z-axis, which this should have a vector input, because you could use a vector input for that, normalized. But here it's just x, y, or z. Yeah, this node is a bit old. Yeah. I guess, yeah, this is basically cylindrical. And again, if you did want to do that, just the simple version, you could just take the normal, cross-product it, and then boom, you've got similar results. Similar result. Wait a minute, why is that showing it on the point when that should be on the face? There we go. Again, somewhat similar, actually, wait a minute. Where's the Z coming from? Yeah, where is the Z coming from on that? I've done tests where they match pretty much one-to-one. Maybe it's because it's like on the face corners, and that's a little weird. Close enough. You get what I mean. Again, cross-product that. Yeah, there's no Z showing up when there should be. Odd. Or is it just glitching? No, there is no Z showing up. No, there really should. I'll need to look into that later. But yeah. Okay. So again, this will be the end of the stream because it is way too hot here. And I don't have my fan running because that would affect the audio quite a bit. But yes, again, here are the nodes. UV tangent, SDF Mesh, normal displace, and all these are in categories in the asset menu. Again, right here, geometry node groups, deform, generate, read, simulation. They're all just there. Ignore that there are double ones right there. That's because I duplicated the setup so that I could demo it without affecting the original, so I will need to delete that after the fact. But yeah, they're all just here. Normal displace, SDF collision, solid extrude, curve to mesh UV, circular array, point grid 3D, velocity step. Easy and nice. What's the best resource for learning nodes like systematically, like under a syllabus? I actually don't, People keep asking about that. The way I learned geometry nodes was just when one was added, I just learned it. But the idea behind nodes is just, like, you just have data, like the position, and this happens per point. Again, wait a minute, here we go. So we just have a value on the points. So this position is like, oh, on particle 1, it's, in this case, let's look at the attribute text. It's just like, oh, it's these numbers, and then this one is that, and this one is that. And then the vector math is, oh, add, we're going to add to that value, and all that stuff. It's always good to visualize what you're doing, either with the color or the attribute text. I like looking at the colors because I first learned vector math through shader nodes, and then going to geometry nodes, it's just like, oh, it's like the same thing, except per pixel, it's per particle, per point, or face, or edge, or whatever. And then for these nodes, like, it's just like, oh, distribute points on faces. That one's pretty straightforward. When in doubt, just check the manual and it'll tell you what happens. And then with the data types, it's just like, oh, normal is a vector is 3 values, rotation is technically 4 values, but you don't need to worry about that. Just a rotation is a rotation. And then with a 4x4 matrix, That one is just a location, rotation, and scale. Do not look at the separate matrix node or the combine matrix node. Just use the separate and combine transform nodes, and your life will be easy. And then the booleans, those are just, 0, 1, on and off, checked or unchecked. So geometry nodes, the logic is pretty simple. It's just, like, there are quite a few nodes out there, and it takes a little while to understand them. Like, the topology nodes stumped me for a while, but then you realize, oh, it's like, oh, you take on the face corner domain, you can get the index of the face on the face corner domain, or the index inside the face. So I guess for a very complicated version, if you evaluate this on the face corner domain, it'll give you, here, let's look at attribute text, the index of the face, which in this case, the face index is 0. If we subdivide it, these corners will be on index 2, these ones will be on index 1, and all that. And then it will tell you the index in the face. So this one is corner 0 of the face, 1, 2, 3. Again, look at the manual if you're ever confused, and always keep in mind, like, oh, what domain is this supposed to be evaluated on? Because, oh, and domains, sorry if I'm not explaining this well. Again, it's late, it's super hot out, and this is just a short stream. But again, with all the domain types, it's just point, edge, face, face corner, spline, instance, and then you don't need to worry about layers because that's just grease pencil. But the main ones are point, edge, face, and face corner if you're dealing with geometry. Because again, a point is just a vertice or a point cloud. They're kind of interchangeable in geometry nodes a little bit. Sometimes you need to convert between them. An edge is just an edge, like if the edge is sharp or not sharp. And then a face is just, a face. And then a face corner is like if you're doing, here, let's go over to vertex paint. We can set this to be face mode, and then let's go and get the color. Let's go and set that to be red. We can see that the face corners are like that, so the data's on there. We can set it to be like only the face, or we can do vertices. So that's actually a good explanation of like the domains. Then with splines, it's just the point of the spline or the entire curve, Yep. So yeah, in conclusion, these nodes are out now on Gumroad for free if you want to pick them up and use them in your projects. Again, they're little nodes that are pretty useful. Some of them are a little bit more complicated than others, but again, it's to simplify things like repeated processes that for projects it would be like, oh, time to make normal displace again. Oh, time to get the UV tangent again. Time to do solid extrude again. Oh, this is the main one. The reason all this was created in the first place. Curve to mesh UVs, because I highly dislike having to make a node group like that that's compatible with cyclic or non-cyclic curves. This was a pain to figure out, and I really hope in the future this becomes a part of the base node by default, because I don't want to ever do this again. But yeah, the node groups there, and the good news about the node groups is that these all work, again, in Blender 4.1 or later. I could have made these a bit more fancy if I did like Blender 4.4 or 4.5, but I want these to be useful in whatever version of Blender I use. And again, I do use Blender 4.1 quite a bit because it has Eevee Legacy, while Blender 4.5 Eevee Next, it actually seems to be, at least the compilation times are pretty similar to Eevee Legacy, so I may be switching to that in the near. Blender 4.5 may be my main going forward. Yeah. But yep, tons of fun stuff. I hope you all enjoy, and I will see you next time. Have a good one.